So hello guys, this is Aman this side, and today I'm gonna tell you something about key value, document, column oriented, and graph database, something all related to NoSQL. So key value database. So key value database are a type of a NoSQL database that is basically not only SQL that stores data as a collection of key value pairs. Consider your name is Aman. So here the entity name has a unique value that is called Aman. So your age is 18. So the entity is age, but the original value is 18. So this is called a key value pair. So is database identify unique key and the associate value. That's what I just told. So these databases are particularly known for their simplicity, high performance, scalability, and very suitable for various applications scenarios. So such as Amazon, DynamoDB, Cassandra, React are some of the examples you would find here for key value databases. Comes the characteristics. So as I told, they're simple, scalable, performance, schemaless. What do you mean by schemaless? All the three are pretty much explained in their single words. Schemaless means like key value databases are schemaless, meaning that each record does not need to be have a predefined structure. So these are advantages and scenarios where the data model is likely to evolve every time, like maybe adding a new columns, adding a new entity, so that helps it to evolve without considering about the previous values. And scalable, simple, performance oriented, document oriented databases are a type of NoSQL database that stores and retrieves data in a format similar to JSON, that is JavaScript object notation. In this model, each document is a self-contained unit containing data in a key value pair format where values can be simple data types, arrays, or nested documents. Their characteristics are document structure, schema-less, querying, use cases, and example. So data is stored in document typically in the format like JSON or BSON, which is binary JavaScript objectified notation. That contains nested structures, arrays, and various data types, allowing for rich and flexible data modeling. So document-oriented databases do not enforce a fixed schema, so they are flexible, particularly useful in scenarios where data structure are subject to change. These databases often provide powerful querying capabilities, allowing developers to query based on the content of the document using a query language or API. Some document-oriented databases support indexing for faster query performance. Use cases, so these can be well used or well suited for a various of applications including catalogs, real-time analytics, situation where the data model may evolve over time. Column oriented, so these are a type of database system that organizes and store data by columns rather than rows. This is in contrast to traditional row oriented databases which store data in rows. The columnar storage model offers advantage for certain types of analytical and reporting workloads. Some of the examples are Apache Cassandra, Google Bigtable, HBase, which is Hivebase, and Vertica. So the characteristics mainly for column-oriented databases are storage format, compression, query performance. So in a column-oriented database, data is stored in columns rather than rows. So this means that all values for a particular column are stored together, facilitating more efficient data retrieval for certain types of queries. Compression. Column-oriented databases often employ compression techniques as columns tend to have similar or repeated values. This can result in significant storage space savings and can lead to improved query performance due to reduced disk, which is input and output. So query performance. Columnar storage is well suited for analytical queries and aggression that involve reading a subset of columns for a large number of rows. This is because the database can read only the necessary columns, minimizing the amount of data that needs to be read from the disk. Some examples are Apache, Cassandra, Google Bigtable, and HBase. The graph databases are an odd fish in the NoSQL pond. Most NoSQL bases were inspired by the need to run on clusters, which led to aggregate-oriented data models of large records with simple connections. So graph databases, what do you understand by the word? So it somewhat contains nodes which are interconnected to each other. They are motivated by a different frustration with relational database and thus have an opposite model, small records with complex interconnections. That's what I've just told. Are a type of NoSQL database designed to store and query data using graph structures. So in a graph database, data is represented as nodes, edges, and properties, which make up in a graph. Nodes represent entities, edges represent relationship between entities, and properties provide additional information about nodes and edges. So a graph structure. So the structure is very dynamic, which is composed of nodes, edges, and different properties of every node and every edge. This representation is particularly well suited for modeling and querying relationships between entities. Relationships in graph database are first-class citizens. They are explicitly defined between nodes and can have properties associated with them. Graph databases often use a specialized query to traverse and query the graph structure. Common graph query language includes Cypher, Gremlin, and Sparkle, used in RDF type of graph databases. Graph databases are schema flexible, allowing for dynamic changes in the data model. The flexibility is beneficial when dealing with evolving or dynamic data structures. Some of the examples of graph databases are Neo4j, Amazon Neptune, ArangoDB, Janus Graph, and examples of popular graph databases. Neo4j is particularly well known and widely used for its focus on graph database data storage and powerful query language such as Cypher. So I hope it was pretty much explanatory. I kept it short and subtle to make it easily understood by you all. And so thank you for hearing me out. So we covered today what the key value, document, graph, and column oriented databases. This is Aman signing off. Thank you and have a great day.